Chapter 5b. Today we're going to talk about imaginary numbers. Learning target. I will be able to define and use imaginary and complex numbers. What is imaginary numbers? Imaginary numbers are numbers does not exist. It was invented to explain the quadratic equations that's not making any contact with x-axis. So it's kind of abstract. Since the graph does not make any contact with the x-axis, why do we define the imaginary numbers? There's no contact at all. That's the reason why it's imaginary. You cannot see it at all. So it's imaginary. So I is defined as, remember this is definition, you have to remember this. I equals the square root of -1. In the past, whenever it's a negative number inside the square root, we say it's not okay. But today, we're going to cover when it is a -1, then that's called imaginary number. And square root of -1 is the unit of imaginary numbers. Unit. So what does I square equal to? I square means you have the square root of -1 times square root of -1. Square root of -1 times square root of -1, that means I can take out the square root, which equals to -1. How about I cube? I cube means -1 times square root of -1, because I get the value from I square and then I multiply another I, which is -I. How about I to the fourth power? So I just use the values from I to the third power, which is -I, and then multiply another I, -I times I, which is -I square. And we know I square equals -1. So from here, you can write it as -1 times -1, which gives you +1. So don't you think it's kind of interesting? After multiply I 4 times, you get back to real number 1. How about you keep going? How about I5? I raised to the 5th power. I raised to the 5th power. So 1 times I equals I itself. How about I raised to the 6th power? I raised to the 6th power equals I times another I. I just used the previous value I to the 5th power times another I. So I have I squared, which is -1. I to the 7th power, so -1 times I have -I. I to the 8th power, so -I times another I, which is -I squared. I square equals -1, so negative times negative equals +1. So it sounds like there's a lot of negative. Make sure you practice multiply negative times negative. So have you seen a pattern here? Can you tell what's the pattern here? If you keep going and fill out the remaining of the table, I to the 9th power, I to the 10th power, I to the 11th power, I to the 12th power, and so on. You can see that with every 4I, we will go back to the same result. Starting with I, followed by -1, followed by -I, followed by 1. And then it starts repeating. I, -I, 1, -I, 1. I, -1, -I, 1. So all you have to do is count how many times can be divided. What is your power being raised to the power 2 divided by 4. So I raised to what power? Divided by 4, and then the remainder would be the I values. So if it's raised to the first power, we know it's going to be I. If it's raised to the second power, if the remainder is to the second power, then that's going to be -1. If it's to the third power, then it's going to be -I. If it's to the fourth power, then it's going to be 1. So this is an interesting aspect for the imaginary numbers. Now we're going to put that into some examples. And again, I would like to remind you, we have to follow the order of operation PEMDAS, meaning that you have to carry out the exponent, and square root is the same as exponent. Square root is the same as exponent, so if you see the square root, it will have to be carried out first. So example number 1, square root of -9. Square root of -9, I can separate into square root of -1 times 9. Square root of -1, so that's the I, the imaginary unit, times square root of 9. Square root of 9 is 3. So the final result is going to be 3 times I. So all I have to do is just replace the square root of -1 as I. Next, we have square root of -9 times square root of -4. Square root of 9, so from the previous example, we know square root of -9 is going to be 3i. Square root of -4 is going to be 2i. So 3 times 2, real number times real number, I have 6. I times I squared. So I squared, we know it's going to be -1. So 6 times -1, that's -6. How about square root of -400? Square root of -400, I can make that into square root of -1 times 400. So square root of -1 is the imaginary unit. Square root of 400 is 20. So that's why you see the answer is going to be 20i. Next, square root of -100 times 36. Square root of -100 is going to be 10i. Square root of 36, which is 6. So 10 times I times 6 gives us 60i. Square root of -50. So this one I wrote it all out. Square root of -1 times 25 times square root of 2. Whenever it comes to square root, I want to factor out the greatest perfect square inside. So square root of 25, I know it's going to be 5. Square root of 2, there's nothing more I can do about it. So I'll just leave it as it is. And then square root of -1 is the imaginary unit. So the answer is going to be 5 times square root of 2 times I. Next, negative square root of 50 times square root of -4. So please notice where your negative signs are. So first, negative. So it's -1 times square root of 50. Square root of 50, I can make it into square root of 25 times square root of 2. Square root of -4. So I can make that into square root of -1 times square root of 4. So are there any perfect squares? Yes, there are. So we have -5. That's from the square root of 25. Square root of 2 times 2. So this 2 comes from the square root of 4 times I. Again, real number multiplied by real number, irrational number multiplied by irrational number, imaginary number multiplied by imaginary number. So our final answer is going to be -10 square root of 2i. Next, we have minus square root of -8. Minus square root of -8. So I break the -8 inside the square root into -1 times 8. And 8, I can make it into 4 times 2. So whenever it comes to square root, think of perfect square. So my final answer is going to be -I times 2 square root of 2. Next, we have negative square root of -8 times square root of -2. So from previous example, we know negative square root of -8 is going to be -2 square root of I. That's what I get from the previous one. And then square root of -2 is going to be square root of 2i. Again, real number multiplied by real number, square root. So the square root multiplied by square root of 2 times square root of 2, that's 2. That's square root of 4, and then square root of 4 can be taken out as 2. I times I, which is I squared. I squared equals -1, so our final answer for this one is going to be 4.